the simple fact is the greenest asset is the asset that's already built. The bridge almost becomes a living organism with a health monitoring device built into it, and we update that data point from maybe a year or 2 years previous. And actually is finding people who are bold enough to take a step with innovative and now proven technology to really drive the outcomes that the asset owner community needs. Because sooner or later, frankly, a bridge is going to fall over.
Did you know that in the UK alone, there are over 3,500 bridges that are beyond their critical design life? Welcome to Innovation Labs. I'm Jack Lee, and I'm joined by my colleague Grace Newey from AtkinsRéalis. Today, we're speaking with Edward Wilkinson from G-Scan, and we'll be exploring how G-Scan's technology helps infrastructure owners make smarter, safer decisions and save millions on maintenance costs. Ed, would you mind just introducing yourself and telling us a little bit about your work at G-Scan?
Sure. So good morning, everybody. My name's Edward Wilkinson. I am the VP for UK Market Development for G-Scan. My background is 25, nearly 30 years in and around infrastructure and technology. My role with G-Scan is really around strategic engagement with the three core pillars of the UK market, which is government and academia, the strategic partners, so the AECs, and then finally the owner operators, the national highways, the network rails. I've been with G-Scan for just over 3 years. As I said, I lead the UK operation. So G-Scan was founded initially in 2018 off the back of some security technology where you had pre-booked slots for trucks crossing borders, and there was a need to validate the contents of the containers. So ultimately, no customs officials, truck, manifest, driver, owner, destination, and point of origin. But evidently, the container needed to be validated when it stated it contained washing machines or car parts. And so the muon tomography was deployed to really look inside the container and validate that information. Very quickly, it was realized that that technology could be deployed in the built environment. And so we developed and further developed the scanners to enable us to really assess the inner hidden critical elements of assets, specifically bridges in the early stages. Although our first project was to help the Estonian Environmental Agency to assess two former Soviet nuclear training submarines that had been left behind when the army left in 1995. Our task was to really assess where the reactors, pressurizers were, and other radioactive material left inside the submarines, which was then filled with concrete to enable these submarines to be broken up safely. The regulator stated that by 2040, they needed to be put into safe store. And we were able to use a single scanner to really map the insides of these submarines to determine where all of the dangerous materials were. We've then subsequently pushed into the UK market in early 2023. We got a bit lucky, frankly, and were able to engage with National Highways. Evidently, the owner of the strategic road network, 4,500 kilometers. So that was our first, albeit test project in the UK, working alongside AtkinsRéalis and National Highways on the Structures Moonshot program, which was really our launch pad for the deployment of our muon tomography technology and our scanners into the UK infrastructure market to help the owner asset community to really assess the safety of their structures.
Ed, thank you for that. It was really interesting insights into G-Scan. I'm curious whether you can tell us a little bit more for the listeners and viewers that maybe don't know what muon tomography is, whether or not you could elaborate on that a little bit more and explain to us how G-Scan are using that technology.
Sure. So look, muon tomography is ever-present solar radiation. The muons are ultimately created as the radiation strikes the Earth's atmosphere. They travel through the atmosphere into the lower atmosphere, striking the planet of the Earth. There's about 10,000 muons hit the surface of the Earth per minute per square meter, and they can travel up to 20 kilometers into the Earth's crust. But we typically allow for somewhere between 10 and 20 meters But the technology can be deployed in tunnels, as we currently are in Japan, and also in bridges. But we've developed some extremely sophisticated electronics in the hardware, the scanners of which we typically deploy two, to enable us to capture the muons as they travel down into the surface of the Earth, where the assets will typically be. And these scanners are able to map the trajectory of the muons as they pass through the scanner, through the asset of interest, and then through the secondary scanner. And the delta, the energy shift, enables us to create what ultimately becomes a 3D image. But we're harvesting vast amounts of data in sort of 5-minute increments, which is then converted into meaningful information to provide that necessary assessment of as I said, the hidden critical elements, which without this, you would be unable to identify things such as cracking in rebar, voids in ducting. So this is ancient solar radiation, combined with state-of-the-art electronics, which enables us to provide this vital information to asset owners to make more considered decisions around their assets from a maintenance and decommissioning perspective, and also actually in assurance. So as built, confirming that the asset is built as was specified in the plans, drawings, and original specifications. So look, I think we're at a very important inflection point where a lot of both Victorian viaducts and bridges built during the Industrial Revolution, particularly on the rail network, but more importantly, on the road network, where you've got the majority of bridges built, 1950, 1960, 1970, are now coming to their end of life moment. So we have considerable estate of assets that are, arguably in some instances critically damaged internally. We are unable to really assess where and the level of challenge that is faced by these assets. And so, with muon tomography enabling, the owners, the AECs to support the owners in that journey of assessment and really taking the critical list and refining it without the need to, physically intervene in the assets. And even if you do physically intervene, you're only intervening in a specific point. So feasibly, you could be a meter out of finding what could be life-threatening damage to the asset. And I think when you consider the aging infrastructure, which is on everybody's minds right now, national highways, network, rail, etc., to be able to deploy technology that is going to genuinely enhance the existing technology, such as ground penetrating radar, acoustic monitoring, to provide a more comprehensive view of these assets, generating vast data sets that will not only be used for the now, but actually will continue to provide value on the ongoing maintenance and observation of this portfolio of assets. There's something like 70,000 bridges in the UK, and that's just the UK. I mean, there are so many countries. The US has a considerable problem with its bridges. So it's a very exciting moment where there is now existing technology that can solve that problem and support governments, local authorities in spending their budgets more effectively.
If we didn't have this technology and we didn't scale this technology, how would you actually solve this problem? Presumably, it's just with kind of armies of people being sent to test things and kind of to drill into things. Is that right?
Yeah, so it's an interesting point. So I can give you a live example. So we were standing on a bridge in London, and the two clients who are two AEC businesses and also the owner of this asset, they had three choices. It was do nothing and hope nothing goes wrong, or, which I think is the point that is the question you're asking, is just to throw money at the problem and probably overspend a belt and braces approach to ensure that the asset is safe. What we bring is the ability to prevent that unnecessary budgetary spend, to really determine where the challenges lie in that asset, and then being very targeted on where the spend is needed to strengthen the asset. If you consider the £1 billion bridge or structures fund that the government announced earlier this year, and you then consider how much money per bridge is available, well, I can tell you it's £35,000 per bridge, and that is not nearly enough. So actually being able to determine where are the critical assets, let's make these critical assets safe, and then actually step back and think where, from a sort of a step-by-step basis, where do we now need to deploy this technology? But as I said, we are a collaborative technology. We are not a silver bullet. We can work with existing technologies, the legacy GPRs, acoustic monitoring and others, to really enhance that journey for the asset owner community.
Just on that point, because I think this is a really important part of everything we're doing in the engineering sector at the moment. We tend to struggle to, especially when you're preventing something from happening, doing preventative maintenance, we really struggle to get that buy-in from people for them to take the leap of faith or put their money up front and say, yes, I'm really committed to making this, preventing these issues from happening. How are you overcoming that challenge, Ed? Because it's something we have to overcome all the time in engineering, whether that be with, wanting to prevent things from going wrong from a process perspective, a design perspective. But how are you overcoming that challenge, Ed?
So look, I think, one of the challenges we face as a business is, the price. Time is a separate issue. We can come back to that later. But if you consider price, so a single scan point, which is about 7 to 10 days, costs £21,000, excluding traffic management. That's not an insignificant amount of money. However, if you start to think about portfolios of bridges, so let's take an example of 10 bridges, in a local authority, for example, and let's say you took 4 scan points, so you spent 100 grand on each bridge. So that's £1 million of spend on 10 bridges. But then you think you're saving somewhere between £4 to £6 million on unnecessary activity and maintenance on these bridges. So we're asking people to think about value over cost, so the outcome rather than the inbound investment. And we're also suggesting that taking a more portfolio and longer term view of how we manage our assets, not necessarily continuing down the same path. So we're asking 2 things. Firstly, partner with us, because the more bridges the more bridges we carry out tests on, the better we become. And actually is finding people who are bold enough to take a step with innovative and now proven technology to really drive the outcomes that the asset owner community needs. Because sooner or later, frankly, a bridge is going to fall over.
And there was something interesting that you touched on there, Ed, right? You were saying, kind of laying out the cost and benefit, that 4 to 6x kind of return on your investment. But it actually goes beyond that, because when you were talking about doing these 10 tests or 10 kind of scans, you now build a data model of the condition of that asset inside, right? So you start to transform the conversation a bit from I'm going to do an inspection and a test and then go away and do something else, to, well, now I'm using data to better manage that asset for the long term. And is that where you guys are thinking and kind of heading?
Completely. And it's a really interesting point, Jack. So as a business, with the successes of Moonshot, you kind of dine out on that, right? Now, what I'm doing currently is engaging with, your colleagues in the AEC community, within the owner-operator community, to get people thinking more around this data-driven asset management. Because if you take that view, undoubtedly, you're going to drive value. So, that need to identify and validate the technology and pushing down this data-driven asset management path, taking that longer-term view, you're going to get a far better outcome. We're going to be able to start to think about these models that, you now have, of the 10 bridges that I used in the example, you're going to have a very firm insight into what that bridge looks like at a moment in time. if you start to then extrapolate that against other assets of a similar nature, you start to build up a very clear path of deterioration modeling, which will enable you in the future to deploy your budget more sensibly, because you'll kind of start to understand certain circumstances, certain environments, and certain, for example, if you're closer to the sea and therefore closer to salt water, it is likely that the ingress of salt into the rebar is going to be greater than a bridge that is in a dry city, for example. So you can really start to build up a very interesting library of asset understanding that will inform decisions way into the future. And also as our technology, is enhanced and evolves, and you start to think about embedded sensors, where you actually have sensors permanently built into bridges. You actually, the bridge almost becomes a living organism with a health monitoring device built into it, where our technology is then just placed by it for a matter of hours, and we update that data point from maybe a year or 2 years previous. So it's a really, really exciting time. And so having partnerships with the likes of AtkinsRéalis, with owner operators, where you really start to build into, that community, you start to see the value of collaboration, the value of technology, and what innovation can bring to, building out that data, that asset management library, which will only enhance the owner-operator community to manage their assets more effectively. Super exciting.
Yeah, you were talking about predictive, maintenance and analytics, right? Is exactly, we need that data to get there.
Yeah, 100%. And the whole digital twin piece as well, which I think is kind of what Ed's touching on here. Like, as different organisations, we see one part of that, and we see our involvement as one part of that. And I think it's really interesting, Ed, hearing your perspective, and you've just touched on collaboration. And I think that's absolutely key to all of this, right? I think that's the biggest issue we've got at the moment is we as an engineering design consultancy might consider our tiny part of what we'd contribute to a digital twin being a design part. But actually, Ed, you're talking about completing that life cycle from an asset management perspective, that predictive maintenance. And I think that is the future of digital twin technology. And as organisations, we need to really actively engage with that collectively. And I think it's interesting, Ed, hearing your perspectives on that, especially from, you're working with clients and asset owners as well as organisations like ours. And I guess it'd be interesting to hear your perspective on how you see these collaborative arrangements working into the future, and how we as AtkinsRéalis can help contribute towards moving better digital twins forward.
Yeah, but I think that digital twins in operations is one of the underrated trends in infrastructure currently. As you've touched on, predictive maintenance, real-time performance monitoring, and other elements. I think we've all got to get out of our silos and actually start to think the common good around the importance of maintaining our infrastructure. We also need to encourage investment into our sector to enable innovation to develop similarly as it has in life sciences, in telecommunications, and financial services. So, I think there's a responsibility in a wider sense for us to allow technologies to be deployed and maybe to make mistakes early doors, but to stick with it, to enable it to step up, to be given visibility to the investor communities, to enable them to see values being delivered. And if value is being delivered, that will further enhance their interest in investing. So there is a broad community that not only the academic, government, owner operator and AEC communities, but also the investment community. Because my experience with the investor community, even in the VC space, has actually been more around more private equity and the need to do deep due diligence, which can go on for years, rather than actually a true VC approach and actually being bold and courageous, and investing in businesses like GScan, and there are many others that can bring value to the infrastructure and the wider built environment.
I'm personally interested to know from a small startup company, how do you continue when you've got this connection with academia? How do you continue to iterate and improve and make sure you're drawing down on that commercial value while still bringing forward the innovations and improving the technologies that underpin G-Scan?
So look, I think, our responsibility is to ensure that we deliver outcomes. Our responsibility is to enhance the technology, to probably look at, speeding up delivery times. But I think what is vital for us is, and actually for the sector, because of the seen and confirmed value that we deliver, is actually finding patrons in the sector, both individuals, practices, and actual large businesses that will invest not money, but time in giving us opportunity to demonstrate the value the technology can deliver. So broadening out the engagement, broadening out the relationships, and giving us opportunity to deploy on more assets. Because ultimately, going back to the point about, data-driven asset management, libraries of data and information on, the journey of a bridge from built to needing maintenance. So having that commercial exposure to innovative thinking individuals within the AEC and the owner-operator community is absolutely vital, way beyond the academic piece.
I think you've touched on it, Ed. But from your time having been at a startup, and as you rightly said, there's exciting things happening, and there's also frustrations at times with our industry. If you had to give kind of specific requests for large organizations like AtkinsRéalis and others that you work with, what are some of the things that you would ask of us to really help startups like G-Scan and others that could really deliver value? You've talked about giving you the time and the space to test things out, but what are some of the things that you would want companies like us to hear to really deliver more value for the industry and for our planet?
So I'm going to answer that in a sort of more broader sense. Having sort of developed a number of other startups in the infratech world, I think the opportunity to co-develop, the opportunity to share the sort of challenges that you face as a business, as an industry with your customers, giving, startups the opportunity to demonstrate, to develop new propositions, but in partnership with, again, this collaboration piece, in partnership with colleagues across the AtkinsRéalis community, where there are different practices doing different things for different customers, creating innovation centers where different commercial challenges from across the built environment can be looked at by yourselves who are at the coalface addressing them, but partnering with the startup communities.
Yeah, it's really interesting actually, Jack. And I know we were talking a couple of weeks back about commercial models and contractual models on projects. And actually what would be really interesting into the future is to see some technology companies, including startups, be a part of that alliance in contract on some of these larger projects where you have multiple organisations sort of sharing that pain and gain. I think that would be really interesting. It hopefully would be a way of, including that early engagement from some of those technology companies who do see things a lot differently to the way that we see them. One of the things, just to sort of touch on the future, Ed, in terms of where you see things going, obviously sustainability is a massive part of what we do as AtkinsRéalis, and I'm sure what you're focused on with the ethos of what G-Scan is about. What are some of the sort of key sustainability benefits that we can see from using technologies like G-Scan?
Well, as we know, the construction sector is one of the largest producers of carbon dioxide of all sectors. So if you start to think about reducing the need for new bridges, so more concrete, you start to think about the broader element of trucking in materials. But at the end of the day, the simple fact is the greenest asset is the asset that's already built. And I was at a dinner a couple of weeks ago where there were a number of significant infrastructure funds in the room with the government. And we were talking largely about renewals. And so the ability to assess an asset in a way that prevents it from being decommissioned and torn down. Not only does it save money, but it brings considerable value from a construction perspective, and reduces the need to produce more concrete, to produce more steel. And then you start to think about as built. You start to think about assurance in the as built world, and you start to think about, how do we build assets that are more robust? So in the future, there will be less need to decommission sooner. And, like I said, the greenest asset is the asset that's already built. And our technology does bring value because it will prevent bridges from being decommissioned. It will prevent the need from drilling into bridges. And in fact, there's an example I can think of on a large UK project where there are some significant challenges around welds on the superstructure of bridges that have recently been built, and where we've been asked to come in as to check the quality of the welds to prevent these bridges having to be rebuilt after a very, very short period of time. So, sustainability, reduced concrete need, reduced steel need, reduced need to decommission bridges, which, there are, I'm sure, far wider positive elements to that as well. But yeah, that to me is the lack of need to decommission a bridge brings about significant, sustainability value.
So Ed, this has been a really great chat, and we've really enjoyed ourselves. I know I have, and Grace has as well. We'd like to wrap up, as with all of our guests, as part of the Innovation Labs, with a few quick fire questions. So short and snappy, 3 questions, and then we can conclude. Does that sound good to you?
Sounds great.
So Ed, first question. What was your favorite invention from the last 50 years that you can't live without?
My iPad. By far and away the best invention ever.
Great. And what book are you currently reading?
So I made a decision that I needed to return to the classics. And so I'm starting with the Sonnets and A Lover's Complaint by William Shakespeare.
Fantastic. And last question. What technology trend would you say is either overrated or underhyped these days?
So I sort of touched on this earlier. I think the digital twin in operations is, really underrated. Digital twins aren't just for design. The real value is in things like lifecycle management, where you've got predictive maintenance, energy optimization, for example, and real-time performance monitoring. You combine that with, other elements to AI and ML with the IoT. You can see significant operational cost reduction, up to sort of 30%, in asset life. And I think that's super important. Again, that comes back to the sustainability part in part.
Fantastic. Well, Ed, thank you so much for joining us today as part of this episode. It was lovely to speak with you and hear your perspectives. I know I certainly learned a lot, and we hope to have you again at some point in the future. For our viewers and listeners, if you could please comment below and join in the discussion. What do you think about some of the things we talked about regarding infrastructure and sustainability and the ways that startups could work with large companies as well? We'd love to hear your opinions on that. And until next time, thanks very much. This has been Innovation Labs.
Architectural visualization is a very slow process, but with real-time engines, that's completely flipped on its head. You can design in the real-time engine. You can see the results immediately. We're seeing a lot more adoption with digital twins, a digital representation of a physical thing. You can even design parametric properties. We are starting to introduce aspects of AI, but we're very cautious. We don't want to take away from any of the creativity that our users are harnessing using our tech.